explore the fundamentals of containerization and see how AWS container services help organizations build, scale, and secure applications with ease. We'll walk through the AWS container ecosystems, dive into the architecture and launch types of Amazon ECS, and look at auto scaling and load balancing to ensure high availability and performance. Whether you're just getting started or looking to fine-tune your container strategy, this session will give you practical insights and best practices you can take back to your teams. We are delighted to have with us Mr. Pankaj Dubey, an experienced AWS cloud engineer and passionate trainer. With 5 years of hands-on cloud experience and over 2 years of training, he brings both deep technical expertise and real-world perspective. Pankaj works extensively with AWS services like VPC, RDS, IAM, EC2, S3, and Terraform. He also holds multiple certifications, including AWS Certified Solutions Architect, Associate, and AZ100 MS Azure Certified IaaS. We are excited to learn from his expertise today. With that, let's get started. Over to you, Mr. Pankaj.
Thank you, Ankita, for the kind introduction. And let me now dive straightly into the world of containers. Okay, so scale and secure with AWS container services. And to start with container services, I want to begin with an introduction on microservices and a monolithic architecture. So first of all, what is meant by a monolithic? Monolithic is entire application is built as a single unit, all code in single executable file. Take any example, or let's take an example of a banking application, iMobile, and in which you can see features as credit card, debit card, PPF. You can check your bank balance. You can create fixed deposit. You can apply for various kinds of loan. Think of like these are the features in a single executable file, and you have made some changes or added more features to a debit card. And this didn't work, and this has affected the entire services. So that is the drawback of a monolithic architecture. One change requires redeploying the entire application. Scaling requires scaling the whole application. And if we talk about the single, this entire application might be in Java, might be in Python. But when we talk about the microservices, application is broken into small independent services. Each service can work independently. Let's take an example of credit card. Let's take an example of debit card, PPF. Everything works independently. Let's say ICICI Bank decides there is an update on credit card, and due to any reasons, there will be a downtime for, let's say, a couple of hours. That doesn't mean you will not be able to do a transaction using debit card. That doesn't mean you will not be able to use other features. That is what the benefit of microservice can be deployed separately. Individual services can be scaled independently. So let's say there are more requests for credit card. Let me scale out the services beneath the credit card. Think of like EC2. There are less transactions for fixed deposit. Let me keep it in limited. I do not want to scale out the services. Think of like resetting a pin of a bank of a card, it hardly takes 2 to 3 minutes. I can go ahead with Lambda as a service instead of running EC2 instance. Why should I run my application on EC2? Why should I run my application on EC2? EC2 running 24/7 and there are only 100 requests per day to reset a pin. Instead, let me use Lambda, which is serverless. Customer request for a reset of a pin, Lambda function will be invoked. It ran for 2 to 3 minutes. I will be charged for 2 to 3 minutes. So credit card I can run on EC2, debit card I can run on EC2, fixed deposit I will use Lambda, for reset of a pin I will use Lambda, and different PPF feature I can use a ECS plus Fargate. And this is what the topic of our, this is what we are going to discuss in today's session. Each service can use different technologies. Each service can use different AWS services. You have written fixed deposit, you have used Lambda, might be in Python. Debit card, credit card, you have used Java. So different, you can use different language. That's the reason enterprises are going ahead with the microservices. So monolithic form, users topics message in a single executable file. And here on the right hand side, you can see users topics messages. Messages are running on containers, topics are running on EC2, users are running on Lambda function. So as I said, enterprises are moving to microservices, breaking big application into small and focused services. These microservices can be built using different languages. Each microservice can be built using different programming languages, Java, Python, Go. Deployment might be complicated, but who solves the microservice? So containers solve this. Okay, we create microservices and containers solve this. They provide a standard way to package and deploy any microservice. So what are containers? They are self-contained environments. They include everything needed to run an application. Nothing but your business logic. What the code is going to do? Is it going to create, once I deploy the container, how it is going to help me? Libraries, settings. This is what a container image contains. So we are going to deploy a simple web application on ECS. I will also show you how to create, push an image to ECR. And after that, containers are fast to spin up and slow down than VMs because containers are lightweight. And when we say lightweight, containers do not contain OS. Instead, they share a virtualized OS. And that's the reason they are lightweight. They can spin up faster when compared to VMs, when compared to EC2 instances. They work across different environments. They can be run on a local machine. They can run on-premises. You can run on any cloud. It can grow and shrink based on demand. Each service run independently, avoid conflicts. Now, if we talk about the example of containerized applications, Netflix, GOT, Hotstar. These are the example of containerized application. When there is a huge traffic during IPL matches or during the World Cup final, we can see views around 5 CR. And this is possible because of containers. So what does a container image contains? A business logic, configuration. Let's take an example, business logic to reset a debit card or a credit card pin. Once the pin is changed, it is going to make an entry into the database, that particular configuration. Dependencies, what is your runtime? Java, Python, whatever. So monolithic order application, here each stack is different. Here you can see on the left hand side, ordering UI, ordering history, inventory, all in a single file. And microservices, there is a common UI, and the front end can interact with these backend services. Each service is independent. That is what the microservice is. Now, what if I want to run simple web application? Where to start? I will start with Docker. So what is Docker? It's a tool that helps developer builds and run application easily. It packages apps into containers, small portable units that include everything the application needs. These containers. So Docker engine. After that, we have something called a Docker file. From the Docker file, we are going to create a build out of it. And once we create a build, a container image will be created. And all the things we do once we install the Docker. Okay, so Docker uses images to create containers, and images like a blueprint that includes all the parts your application needs. And when we talk about all the parts, these are the things. So containers on AWS. I said containers we can run on premises, we can run on a local machine, we can run on AWS, we can run it on AWS EC2 instances as well. But what are the challenges if I run my containers on EC2? I need to take care of the maintenance. I need to take care of patching. I need to take care of EC2 auto scaling. I need a load balancer. All these things I need to do if I run my application, if I run my containerized application on EC2. But what if I use an orchestration tool like ECS, Elastic Container Service? It is a completely product by AWS, makes things easier by managing scheduling, when and where the container should run. Choosing the best compute. We will discuss different type of compute offered when we run a task on cluster, networking, connecting containers securely so that they can talk to each other, monitoring, tracking the health, performance, and resource usage of containers. So if we talk running containers on EC2, I need an EC2 instance. But when we talk about containers with an orchestration tool, the benefit is scheduling, placement, networking, and monitoring. 70 to 80% of the things are managed by the orchestration tool itself. So first, if I want, we will discuss about ACR and ECS. So I am going to push an image here, and this image I am going to run it on ECS. So ECR is Elastic Container Registry. It's a regional service, secure, scalable, and reliable container image repository. ECR is the service where I can store, manage container images. If we have worked on Docker Hub, AWS came up with its own service, ECR. It's the private Docker registry on AWS. You can store and manage your container images on ECR. So let's go to ECR. ECR, Elastic Container Registry, fully managed Docker Container Registry. Let's go here. And what we do inside a registry is we create a repository. Private registry. Inside the registry, we create a repository. So what is the name of the repository? Let's keep it as AWS ECS. Image tag immutable. I am selecting mutable or immutable. So if you push image with the same tag, it will fail. So that is the meaning of mutable and immutable. Encryption, do you want to encrypt with AES-256 or you want to use your own customer managed key. Let's keep it simple. AES 256 and plus yes. Simple. Let's create. What we have done, we have created a repository. Now, once I click on this repository, I need an image. I need to push an image. Okay, so if I click here, view push command, I need first a Docker file. I need first a Docker file. Inside the Docker file, there should be a script. From this script, I'm going to create a build out of it. Once I create a build, container image will be created. I will push this image to ECR. And for this, I have an EC2 instance where I'm going to do all these things. Okay. So I have an EC2 instance. I have logged into it, build your Docker image using the following command, and I'm going to take help of the documentation. So this is AWS documentation for ECS for creating a container image. So first, if I go here and if I run Docker version, Docker not found, what I need to do? I need to install the Docker. Install the Docker. Let's try to do this. So let's follow the steps and let's try to build a Docker. Let's try to build a container image. So dependencies are resolved. Install the most recent Docker community edition package. Let's install the Docker. Once we install the Docker, I will start the Docker sudo service Docker start. System, and I can run this command sudo user mode. You can execute Docker without user. EC2- is the user, no problem. But let me execute this command. And now let's try to check Docker -f version. It should say Docker version 25.0.8. So now we have installed Docker. Next is we need to create a Docker image. To create a Docker image, I'm going to create a file first. So let's again quickly create a Docker file inside which there is nothing. There is so here there is one Docker file, and I'm going to use the same content. I'm going to use the same content. So let's give a message. Let's come to AWS ECS. This is the message. Let me put here we are in Docker find. Paste. If I try to see what is the content inside the Docker file, this is the content. Welcome to AWS ECS webinar. This is what the message I'm going to give here. Okay. So now Docker file is ready. Once it is ready, I need to create a build out of it. Okay, so build your Docker image using the following command. So Docker build -t AWS ECS webinar. This is my repository name. Let me clear here and let me paste it here. So AWS, so Docker build -t AWS ECS webinar dot. Create a build from the current folder. There is a file, Docker file, and this dot represents from the current folder, and a build will be created. Once Once the build is created, what we need to do is I have an EC2 instance. Here is the build. Here is we have created a build, and it is we call it as a container image. Image will be created. Now I need to push it to ECR. EC2 is a service, ECR is a service, service to service communication. IAM rule is required. Plus, we also need to authenticate between where Docker client is installed and between the registry. Okay, between the registry. So here, if I write Docker images, you can see one image. Now, if I want to push, retrieve an authentication token and authenticate your Docker client to registry. Let me copy this command. Let me clear this. And if I try to execute it, I am going to get an able to look at credentials, and hence I need to assign a IAM role to this EC2 instance where Docker client is installed. Actions, security, modify IAM role, EC2 ECR, update the IAM role. Again, I'm going to run this command, ECR get login password, region, Docker login, and let me run this command, and it should say login succeeded. So what we have done here is we have established connection between the Docker client and the registry. Build is completed. The third step says once after the build completes, tag your image so you can push the image to repository, and I need to push the image to the repository. As of now, my image, the container image which I have created, is on the EC2 instance. So Docker tag this one to this one. Okay, so let's select Docker images, AWS ECS webinar latest, tag it as this one. Okay, so that's the reason I'm running this command. Again, I'm going to run Docker images. It is tagged. Now what I am going to do, I am going to push the image to repository. So let's run the following command to push this image, Docker push this one. So let's close here. We do not have image here, and let's run this command. Image is being pushed to the registry. Image is being pushed. Let's wait for 5 to 10 seconds and I should be able to see the image. Okay, I'm able to see the image. Image is created. Now what my role is, I should run this image on ECS, Elastic Container Service. It's a fully managed orchestration service that helps you manage containerized application. I'm going to show you how it can be integrated with load balancer, and we can create containers for your micros. We have created an image, and we are going to run containers and orchestrate them using these services, ECS and Fargate. So what we do in ECS, we create a cluster. What is a cluster? Logical grouping of compute services. Might be EC2 instance, might be a Fargate. So ECS cluster is a virtual environment where you run your containerized application. It groups compute resources. It acts as a foundation for orchestrating containers, managing tasks. So let's discuss one by one, and let's go to ECS, Elastic Container Services. So ECS orchestration tool to run containerized application, and what we do in this one is we create a cluster. Create a cluster, and whenever we create a cluster, it will give us random name, and I'm going to give a name AWS ECS webinar. Now select a method for obtaining compute capacity. So where I want to run this container image, should I run it on Fargate? Should I run it on Fargate and managed instances? This is new. So Fargate managed instance is nothing but EC2 instance managed by AWS. What is managed by AWS? Maintenance of the EC2 instance is managed. What is maintenance? Patching and scaling is managed by AWS. Fargate and self-managed instances, EC2 instance managed by customer. This is what the details are. So I'm going to keep it simple. Let's run it on Fargate. What is a Fargate? Serverless way of running containers. Serverless way of running containers, and I'm going to create a cluster. Once I create a cluster, the cloud formation template is created. So cloud formation infrastructure as a code, and again here you can see the template to create a ECS cluster. Cluster is created. Inside the cluster, what I need to do? I need to do a task. I need to run a task. If I click on run a task, it is saying task definition family. It says task definition family. And what is meant by task definition? Blueprint for the application. Task applications such as a single web application, batch job that perform work and then stop. That is a task. So what is inside a task definition? So first we have a task definition. We have inside the task definition container definition. So let's go here, and here I can see task definition. I need to first create a new task definition, and let's create a task definition. So let's say AWS ECS task definition. Launch type is Fargate. Operating system is Linux. For tasks, 1 CPU, 3 GB of memory is more than enough. Task rule. Task and will allow continuous in the tasks to make API requests. That means that application can make requests to AWS services. Let's think of like here in the container -1 container definition, I have given one image, and that image is to reset the ping. So somewhere it should store the new ping. So application should have that access to make API requests to AWS services like RDS or DynamoDB. Execution role. If the task want to fetch secrets from secrets manager, execution role. So let's keep it simple. I have just defined what I have defined is the capacity to use, which determines the infrastructure. Docker image, we will give the Docker image, how much CPU and memory, the memory CPU requirement, and the operating system we have defined in the task definition. Container definition. Inside the container definition, let me write here as AWS ECS container definition. Image URI. I will get the URI from here. Private repository. This is the repository latest, and let me copy the URI and let me paste it here. Container port 80 TCP. Yes, I want everyone to access the application. These are the ports, and that's it. So inside the task definition, I have defined one container definition. Likewise, you can define up to 10 container definition. So best practice is one task definition, one container definition, and let's click on create. we have created a task definition. Now our next task is to run the task on this particular cluster. Click on task, run a new task, and now I can see there is a task definition. Number of tasks. As of now, I need 2 tasks. Compute option, launch type is my target, platform version is latest. Networking, I want to, as of now, let me keep it as simple, VPC, default VPCs. Do you want, I do not want an existing security group. Security group, it is nothing but a firewall, and it is a firewall where we can define inbound groups who can access the containers. So let's keep it as name as ECS security group. And I will open the ports HTTP for everyone so that everyone is able to access the web application, simple web page. And that's it. If we click on it. Task desired state is running, last state is position. So I have mentioned a couple of tasks, and these 2 tasks are running. So if I go to the slide, so launch Docker containers on AWS, you do not provision the infrastructure, it's a serverless offering. AWS just run containers for you based on CPU RAM you need, and just tell AWS how much CPU and memory you need. That is nothing but running the serverless in running the containers in serverless fashion. And we have seen ECS cluster. So types of ECS cluster, we have discussed ECS managed instances, AWS managed, EC2 instances for you. So let's say here you do not get more flexibility. Let's say you have some applications like gaming application, you need GPU support. Here you can select the EC2 instance, which has the GPU feature. Most workloads need simplicity and control. Forget rapid deployment, unpredictable workloads. EC2 instance, you manage the EC2 instances yourself. Launch type, we have discussed EC2 and forget choosing the launch type. So here if you see GPU support, yes. Complexity a little bit higher because you need to manage many things. Forget is low complexity. Scaling will be managed by AWS, and that's the reason we call it as the serverless. So task execution IAM role. So first task IAM role, as I said, the application wants to make an entry into DynamoDB. Task IAM. As this task execution IAM role is assigned to an ECS agent, not your application, to pull container images from ECR. So this is what the importance of roles. Now let's come here and see what is the status of the task. It is running, last status is running, and I should have a public IP. Let's see if we get the response. Welcome to AWS ECS webinar. So this is how you run a task on ECS cluster. Now what if I want to add a load balancer and auto scaling for the same task? I can make use of this service definition. Let's go to the task. First, let's stop these tasks. Stop all tasks. Once we stop this, status should be stopped. Now let's assign a load balancer, application load balancer, and an auto scaling group via the service definition. So create. What is our task definition family? Task definition family remains the same. Launch type, it is a forget. Desired number of tasks, let me keep it as 5. That we have, let's keep it as 6 because we have 6 subnets inside the default VPC as we are in North Virginia region, and I turn on auto zone rebalancing. That's fine. And I need load balancing feature. I need a load balancer, application load balancer. Name of the load balancer is AWS ECS ELB. Listener, AT is fine, HTTP is fine. Target group, let's keep it as target group 5. So whatever the task, design number of tasks, 6 will be registered inside the target group. I also need service auto scaling. Minimum number of tasks should be 5. Maximum number of tasks should be 40. When should the number of tasks be increased? Do I need AWS our scaling policy type target tracking? So let's keep it as average CPU target tracking policy. When the average CPU utilization of all the tasks running goes above 50, increase, there should be a scale out. Target tracking, increase or decrease the number of tasks that your service runs based on a target value for a specific metric called CPU utilization. So this is what the target tracking policy. And that's it. And I will click on it. Okay, so we have created a service definition. Now, if I go to the EC2 instance, a load balancer, I should be able to see a load balancer is provisioned. If I go to the target groups, this is a target groups. 6 targets should be registered here. Okay, and once we create a load balancer, we get a DNS name. Okay, so we are going to access our application via DNS name once the deployment is in progress. So first we started with microservices, monolithic application, the difference between them, why containers and microservices are used, what is inside a container image. We discussed in short about Docker, containers on AWS, what are the AWS services which offers what are the AWS container services to run containerized application. We discussed about ECS, orchestration tool, running containers. We created a registry. Inside a registry, we have created a repository, and we have pushed a simple image to ECR. Registry, ECR. What are the orchestration tools? ECS, EKS. We have used ECS. Container hosting, where I can deploy my container. On Fargate, it is a serverless way. On EC2, infrastructure as a service. I want to run in a serverless fashion because I do not need a maintenance overhead of the underlying infrastructure. I am ready to pay the price. I will go ahead with AWS Fargate. ECS is a fully managed container orchestration service that helps you to easily deploy containerized application. We have integrated it with a load balancer as well. And what we do inside ECS is we create a cluster. It's a logical grouping of compute services. We talked about ECS managed instances, Fargate, EC2 instances. We talked about task definition. We discussed about the container definition and serverless. So Fargate is the way where we can run containers in a serverless fashion. And we have assigned a load balancer to our task. Launch type, this is done. We have discussed this, and load balancer. So Amazon ECS integrates seamlessly with Elastic Load Balancer to distribute traffic across your containerized services for high availability, scalability, and fault tolerance of the tasks. Okay, so it's still in progress. Let's see. So here, if I go to the EC2 instance, if I go to the load balancer, I will get a DNS name. Let's check if it works. It is not HTTPS, it is HTTP. Still it is in progress. Let's wait. Let's wait. It is still in provisioning state. It is active. Let's go to security. Okay, we have assigned a default security group. Let's click on edit. We can use the ECS SG security group. Let's click on save changes. And if I go to the security groups, ECS SG, inside which I have opened HTTP and HTTPS ports. And if I try to access it now, I should get the same message. Balancer. This is balancer. DNS name. Inside the target groups. No target registered. It's not healthy. Okay, target registration has been failed, and that's the reason we are not able to see the message. Else, we should be able to see welcome to the same message what we got after running for task. So there has been some change. I'm not sure why it is showing as unhealthy. Let's go here. Custom service name. As unhealthy. Tasks are in running state. Let's go to this particular tasks. Let's copy this IP address. Let's try to see. Systems. Okay, so this what the output we are expecting here is if I go to the load balancer. If I go to the load balancer in the security groups, I have assigned the same security group, and if I copy the DNS name, I should see the same message welcome to this webinar. But somehow the targets are not registered healthy. But the output is like output should look like welcome to AWS webinar. But these are the steps how we can register targets, how we can create a service definition, and we can create multiple tasks. So this is how we can integrate a load balancer with ECS tasks. So Ankita, I am done. Over to you. I'm done.
Oh, okay. Sure. So thank you very much, Mr. Pankaj Dubey, for such an insightful and engaging session. And to our attendees, it's been wonderful having you with us today, and we are grateful for your participation. Now, if this session has encouraged you to explore more on scale and secure with AWS Container Services, I invite you to look at our virtual instructor-led program training programs at springpeople.com. These are live sessions conducted by certified trainers and can be attended from the comfort of your home. Now, if you do not find a batch that matches your schedule, we can arrange private group sessions or recommend flexible self-paced courses that you can take at your convenience. For more details, you can write to us at training@springpeople.com or call the number on your screen. Our team will be happy to guide you further. Now let us move into the Q&A segment. Over to you once again, Mr. Pankaj. Thank you once again for your active participation. The recording of today's session will be sent to your registered email address shortly. So please do keep an eye out for it. Now, before we close, we would love to hear your thoughts about today's session. Please take a moment to share your feedback with us. Your reviews will really help us improve and make our future sessions even more valuable for you. Until next time, keep learning, and we look forward to having you in another Spring People session. Take care and have a wonderful day ahead.